Okay, scientific notation. This is going to be something, this is a decimal or integer times 10 to some integer power. Okay? An illustration might be 2 quintillion. That's 1, 2, 3, 4, 5. So I need another 7 zeros. Okay, that is a quintillion. Okay? In scientific notation, that would be 2 times 10 to the 18th power. Okay? Yeah, it's a space saver. Okay? It saves space, it saves time. Or another way you might see this written is 2 with a times dot times 10 to the 18th. That's another way you may see this written. Okay? So let me pause this and let me show you how to convert to scientific notation. Okay, now I want to talk about converting to scientific notation. There's 2 cases. For numbers that are greater than 1, move the decimal point to after the first digit, and you will have a positive power of 10. Okay? If it's a decimal that's less than 1, move it to after the first non-zero digit, and the number of places moved becomes your negative power of 0. Okay, so example 1. We're converting to scientific notation. So let's say I have 205, or let's say I have 20,521. Okay, this is equivalent to 2,521, and that's equivalent to 0.1. Move the decimal point until it is after the first digit. Here. Okay, and we would get 2.052. We don't need the extra 0 if it's after a decimal point, times 10. We moved it 1, 2, 3, 4 places. So the power of 10 is to the 4th. Okay? Example 2. 12,000 or 122,580. Well, that's equivalent to 122,580.0. 1, 2, 3, 4, 5. Okay, so this will be 1.2258. We don't need the extra zeros if they're after a decimal point. Times 10. We moved it 1, 2, 3, 4, 5. So 5 places. Okay? Something like this. 0.000295. Well, 0.2905. What you're going to do is we're going to move, this is the decimal, it's less than 1. We will move the decimal point until it is after the first non-zero digit. That's this one. So we have 2.905 times 10, and we moved it 1, 2, 3, 4 places, and that's going to give me negative 4 because the exponent needs to reflect a small number. Okay? Example 4. 0.32. 0.32, we will move it to after the first non-zero decimal place. So that gives me 3.2 times 10. We moved it 1 place, so negative first power. Okay? Let me do another example right here. Example 5. Okay? Let's say I have 253, or how about 253.79? Okay? And I'm going to change this to 453. Well, it's already a decimal. But keep in mind, it is still a number that is greater than 1. So we're going to move it to right there. And we have 4.5379 times 10. We move the 2 places. It's larger than 1, so it's going to be 10 to the positive second power. Okay? All right. I'm going to pause here and get converting from. Okay, in scientific notation, we don't have the times 10 to whatever. So ultimately, we want to get rid of that. So here's some facts. If the power of 10 goes up, the decimal point goes to the left. Okay? If the power of 10 goes down, the decimal point goes right. One way of thinking about this is that scientific notation is downright scientific. Downright scientific. Okay? So if I have 5.3 times 10 to the 7th, then I'm going to have 5.3 times 10 to the 7th. Actually, since the decimal point can go either way, what I propose to do is put this in the middle and put some distance on it. Now, we want the power of 10 to go down to 0. So I'll be taking 7 away. Now, if the power of 10 is going to go down 7 units, the decimal point needs to go to the right 7 places. Okay? If the power of 10 is going down 7 places, then the decimal point needs to go right 7 places. So I got my 5. I'm going to put in a 0 at each and every one of these humps. Okay, and then 1, 2, 3, comma, 1, 2, 3, comma. All right, and I'm done. This is equivalent to 6.0 times 10 to the 4th. We need to go down a power. We need to go down 4 powers. And again, if the power of 10 goes down 4 powers, the decimal point goes right 4 powers. So 60, and then I have 1, 2, 3. And I'll put a comma before the third digit. Okay, this is going to be a small number. Okay, 7.8 times 10 to negative third. Now to get to 0, we need to go up 3. Okay? So if we're going up, the decimal point needs to go left. So 1, 2, 3. 7, 8, 0, 0, decimal point, and then I'm going to put a 0 before it. Okay? And that is how we convert from scientific notation. Okay, I would like to add a little bit more detail about scientific notation using the number 58,642.137. All right, so I'll start with the big parts. This is 58,000, so this represents the 50,000. That's 5 times 10,000, or 5 times 10 to the 4th. This is 8,000, so 8 times 1,000, 8 times 10 cubed. This represents 600. 6 times 100 or 6 times 10 squared. This is 40, which is 4 times 10, 4 times 10 to the 1st. This is 2 ones. Okay, the ones place is a 2, so it's 2 times 1, which is equivalent to 2 times 10 to the 0. So let me go over here and I will add smaller numbers. Okay, this is 1/10, which is equivalent to 1 times 1/10, which is equivalent to 1 times 10 to the negative 1st. This is 300ths, which represents 3 times 1 100th, which is 3 times 10 to the negative 2nd. Or let me make these even more clear. This is 1 over 10 to the 1st, which is 1 times 10 to the negative 1st. Okay? This is 3 times 1 over 10 squared, which is 3 times 10 to the negative 2nd. And this represents the thousandths, 7 1,000ths, which would be 7 times 10 to the negative 3rd, or 7 times 1 1,000th, which is 7 times 1 over 10 cubed, which is 7 times 10 to the negative 3rd. If I throw in another 9 here,
That's the 10,000ths. That is 9 10,000ths, which equals 9 times 10, sorry, 9 times 1 10,000th. And 10,000 is 10 cubed, so 9 times 1 over 10 to the 4th, which is 9 times 10 to the negative 4th. Hundred thousandths, 10 to the negative 5th, millions, 10 to the negative 6th, and so on. Okay? So, I'm going to pause here and start putting up real application type problems. Okay, suppose a locality has 253,000 working adults. If their average income is 29,000, A, convert both to scientific notation, B, use that to estimate total income. So do A, 253,000.0 times 10 to the 0th for now. 1, 2, 3, 4, 5. So I went left 5, that means I'm going up 5. Okay, so that's 2.53 times 10 to the 5th. And 29,000 times 10 to the 0th. Let me put that decimal point as 0. Times 10 to the 0th for now. 1, 2, 3, 4. So that is 2.9 times 10 to the 4th. B. So that's going to be 2.53 times 10 to the 5th people times the amount of money. 2.9 times 10 to the 4th. So people times money. So I will take my calculator. I'll go ahead and take, what I recommend you folks do is I'll take 2.53 times 2.9. That gives me 7.337 times. When you're multiplying, you can just add the exponents. 5 plus 4 gives me 7.337 times 10 to the 9th. So that's approximately how much money is being made here. Okay? 7.337 billion. Okay. This next example is similar. Suppose a region has 4.3 million working adults. If their average income is $28,000, A, convert both to scientific notation, B, use that to estimate total income. So, 4.3 million is actually very easy. 4.3 times 10 to the 6th, because a million is 10 to the 6th. Okay? 1 million equals 10 to the 6th. 1 billion equals 10 to the 9th. 10 to the 9th. So, that's 4.3 times 10 to the 6th. That's going to be very easy to do. Okay? Then we have $28,000. 28,000.0 times 10 to the 0th for now. So 1, 2, 3, 4, and that is 2.8. We went left 4 places, so up 4. 2.8 times 10 to the 4th. So, use that to estimate total income. So 4.3 times 10 to the 6th people times 2.8 times 10 to the 4th dollars. So I'm going to multiply the decimal part. So 4.3 times 2.8. 12.04 times 10 to the 6 plus 4th. Because when you multiply, you can add the exponents. So I have 12.04 times 10 to the 10th. However, this decimal must be strictly less than 10, and it's not. Okay? So, to the left 1 place, we go up 1. So that's 1.204 times 10 to the 11th dollars. Okay? All right, I'm going to pause here and put up another example. Okay. Now, up here, I've fictitious region, Gascania and Queensland. Here's their fictitious populations, 8.6 million, 12.3 million. Here's their number of teachers. Now we're going to do teachers per capita as a decimal to 6 decimal places. So I'll go ahead and move this over. Teachers per capita. Per capita means per person. It comes from Latin for per head. Okay? So, you're always going to be dividing by your population. So, here's what we're going to do. So, we want teachers per capita as a decimal to rounded to 6 decimal places and scientific notation. And then finally, I want teachers per 100,000, rounded to the nearest person. So, do Gascania. You will always be dividing by the population. You will always be dividing by the population. No ifs, no ands, no buts. And remember, 1 million equals 10 to the 6th power. Okay, that's going to come in helpful. So anytime you are doing per capita, you are dividing by the population. The population is 8.6 million. Okay? Be sure that when you're setting this up, you must use parentheses. On your calculator, or this will be wrong. Okay? So we're dividing teachers per capita. So teachers, there are 89,000 of them. Okay, so on my calculator, I type in 89,000 divided by. I hit the open parenthesis button. $8.6 times 10. My generic exponent button, and then I have a 6 in the exponent, like so. Okay? And then I balance it with a closed parenthesis, like so. Then I hit enter. And what comes out of my calculator is 0.01, 03, 488, 3721. Okay, that's what came out of my calculator. We're rounding to 6 decimal places. So 1, 2, 3, 4, 5, 6. Okay, the next digit is 5 or greater, so we're rounding up. 0.0103, 4, and here's the 8 decimal, here's the 6 decimal place, the next digit was 5 or greater, so 9. Okay, so I also want scientific notation, so that's going to be 0.010349 times 10 to the 0th for now. Move it to the first non-zero decimal place, and I get, if I went, it's down right, so if I went right, I go down 2. So this is 1.0349 times 10 to the negative second. Okay. Teachers per 100,000 people. Okay, so I'm going to take this number, either one of these numbers. I could either take 0.010349 times 100,000 people, or I could use the scientific notation. It really doesn't matter. So, 0.01, 0.01, 0.0349 times 100,000. Okay, 1,034.9, which rounds up to 1,035. Okay, we're going to repeat the process for Queensland. I'm going to start from the beginning. All right, so it's teachers per capita as decimal to 6 decimal places. So we are always, so it's Queensland. Queensland is next, and you are always dividing by the total population. The total population is 12.3 million. Okay? You are going to always have total population second. No ifs, no ands, no buts. Okay? The other number to be divided by is the number of teachers. That's going to be the 136,100. So, I'll do 136,100 divided by, I'm going to convert this to 12.3 times 10 to the 6th. Now, technically speaking, this is not scientific notation because the decimal is too large. But I'm not worried about that because I'm just trying to get this and this. Okay? So, 136,100 divided by, parenthesis, 2.3 times 10, your generic exponent button, 6. Scroll out of the exponent if you have to, parenthesis. I got 0.011065.04065. 6 decimal places. So 1, 2, 3, 4, 5, 6. Pretty self-explanatory, okay? I'm going to be rounding down. So 0.011065. Scientific notation. Ten to the 0 for now. Move it to the first non-zero decimal place. It's down right, so if I went right, I go down. 1.1065 times 10 to the negative second. Okay, and then to get the teachers per 1,000, I'll take this number times 100,000, where I have room. So, take this number times your 100,000 people. Okay, so I end up with 1106.5, which I will round up to 1107. Okay.